Normally, oh, hi, that's awkward. Normally, how many points do you need to have for slope?
Two.
But with the derivative, you only need how many? Perfect. Okay. So, taking a look at your notes for today, at the very top, you're just going to draw in some tangents. Okay. So, for number one, it says to draw in the tangent line in -2. So, you would count back to -2. That would put me about right here. Because remember, you want to be like on the graph, okay? And then you're going to draw your tangent line in so that it lays perfectly next to your curve, but it should really only cross at that one point. Remember, if it crosses at 2 points, that makes it a secant, okay? So I'm going to draw my tangent in, okay, just like that. Okay, then the question says, is f prime of -2 positive, negative, or 0? Well, look at the line you drew. Is it uphill, downhill, or flat? Okay, then that makes f prime positive. Okay, for my next one, I want to draw the tangent line in at 1. So find 1 on your graph. 1 would be about right here. And then if I'm drawing the tangent in on either like a hill or a valley, okay, at that top or bottom of your graph, it should be perfectly flat. So it would be just like this. Okay, remember your tangent line should just touch at that one spot, and then how would your f prime be? Positive, negative, or 0? Correct. Okay, then how do you know? Let's just put it's a horizontal slope. Or if you want to put flat, that would be fine. Okay, horizontal slope. This was an uphill slope. Okay, and then hopefully you kind of get the idea. Do you get the idea? All right. So what we're going to do today, last time we learned how to find the slope of those lines. Today, we're going to write the equation for those lines. Okay, so in order to do that, you have to remember how to write an equation, but you learned this in Algebra 2. So there are 2 forms for a line that you should know. First one is y equals mx plus b. We remember what the m is? Yes, which now we know how to find. Okay, and then the b is the y-intercept. Okay, which is just wherever your line crosses the y-axis. Now, if you have a point that is not the y-intercept and the slope, you can still write the equation of the tangent line using point-slope form. So point-slope form is y minus y1, mx minus x1, where m is your slope, and then your point, let's say your line passes through point x1, y1. Now, typically, if you're doing this equation, it's because the point that you have isn't the y-intercept. If you had the y-intercept, you'd probably just do y equals mx plus b. Okay, but this is usually going to be for a point that's not on the y-axis. All right, so take a look at number 1. Okay, it says, given that f of 10 is -3 and f prime of 10 is 1/2, write the equation of the tangent line to the graph of f at 2. Okay, regular f is going to tell you the point. Okay, there are 2 ingredients that you need to write the equation of a tangent line. You're going to need a point and you're going to need a slope. Regular f tells you the point. And if they tell me f of 10 is -3, that means that 10, -3 is the ordered pair. The second thing that I need is the slope. And remember that for a slope, we learned last time, okay, that f prime is the equation for slope. And they're telling you the answer right here. What is f prime of 10? 1/2. Very good. So then using those ingredients, you're going to write your equation of your tangent line. I cannot start with y equals mx plus b because I don't know the y-intercept, so I'm going to start here. So here's how we're going to write it. Y blank equals blank x blank. And then we're going to fill in the blanks with the numbers for our problem. So the middle should be my slope, which we already know. What is it? 1/2. And then because your x1 and your y1 have negatives built into the formula, you're going to have to switch the sign when you plug them in. So what I mean by that is like if my x is a 10, I'm going to put a minus 10 here because it's part of the formula. Okay, then my y is a -3, but a minus a -3 would switch it to a +3. And then that's the equation of the tangent line. Now, sometimes, especially on the AP test, for your homework, this is good enough. But sometimes they'll give you answer choices where you have to pick one in y equals mx plus b format. If that's the case, you just have to know how to convert it, but it's very easy. You're going to take the half and distribute it in. So I would have 1/2 x. And then what's my 10 when I cut it in half? Okay, y plus 3 equals. And then we're just going to get rid of that +3, subtract it across from the 5. So y equals 1/2 x minus 8. Okay? But keep in mind that both of these answer the question and are correct. Okay, the only difference is if you're required to put it in slope-intercept form or if you can leave it like that, which for your homework today, this one's totally fine. You can solve it if you just want to, but you don't have. All right? Go on to the next page, please. So for the first one, you kind of had the pieces handed to you. Okay, for the second one, okay, we're going to have to use what we learned last class. So you have a picture of a graph. Okay, and then it says, write the equation of the line tangent to the graph, 3x squared plus 5 at x equals 1. So we just learned this a second ago, but what are the two things you need to write the equation of a line? Slope and a point. Very good. So let's do point here, slope here. Now, if they're telling me that my x is a 1, that's already part of the point right there. So I'm going to go ahead and put 1 comma something. And then in order for me to find my y value that goes with that x value, all that I'm going to do is plug x equals 1 into the original f of x function. So if my x was a 3x squared plus 5, we're going to have 3 times 1 squared plus 5. And then remember with PEMDAS, you're going to want to square first times second. So 1 squared is still 1, and then 1 times 3 is 3 plus 5 is 8. So we have our point. We have an x, we have a y. Second thing that we need to find is our slope, and we just learned how to take derivatives last class. So you're going to take your f, and you're going to find the derivative, and then you're going to plug your x equals 1 into the derivative. Okay, because remember, derivatives tell you slope using just a single x value. So let me remind you what the power rule says for derivatives. You're going to take the exponent, times it down to the front. So if it was a 3x squared, what's 2 times 3? 6. And then I'm going to downgrade the power by 1. So now it's a 6 with a regular x. Does anyone happen to remember what happens to a constant when you take the derivative? Goes to 0. Very good. 5 is a constant, which means derivative goes to 0. Okay, this is the equation for the slope at whatever point I want. I want it at point x equals 1. So we're going to plug a 1 into that. 6 times 1 is 6. And then from there, we're going to write our equation, put it in point slope form. So it'll be y blank equals blank x blank. Remember, your slope goes into the middle spot. Your x and y are going to go in as opposites. So my 6 will drop right here into that middle blank. And then remember, if my real x is a 1, I'm putting a -1. My real y is an 8, I'm putting a -8. Those are built into the formula. Okay? Now, if you go down to part B, just to kind of give you like a graphical visualization of this. Okay, we're going to graph the tangent line to confirm tangent C. So remember, on the first page, we were kind of sketching the tangent line. Okay, now we're going to actually graph it. So in order for me to graph it, I'm going to turn this into y equals mx plus b, which we just did on the front, times that 6 in. So 6 times x is a 6x. 6 times -1 is a -6. And then in order for me to get my y by itself, I just need to undo that -8 with a +8 on both sides. Which means that my equation of my tangent line is 6x plus 2. All right, so now we're going to take this equation, we're going to graph it, and it should be perfectly tangent to your parabola at the point 1, 8. So let's see if that happens. Okay, remember 2 is the y-intercept, so graph it on your y-axis. That's your B. And then for your M, if it's a whole number, how can we make that a rise over run? Put it over what? 1. So I'm going to rise 6, run 1. So 1, 2, 3, 4, 5, 6, run 1. 1, 2, 3, 4, 5, 6, run 1. And then when you draw your graph, it should just perfectly touch the function just at one point, and it should perfectly match how steep the parabola is at that spot. Okay, because that's what we said a tangent line is last time. Okay, so your tangent line, so it should touch at 1/8, and it should have the identical slope to how steep the parabola is at that same spot. Questions on that? All right. I think we're going to do maybe 2 more, and then we'll take a little homework break. Okay, so take a look at number 3. We have a new equation. Okay, an 8x squared, and we're going to write the tangent line at -4. So my 2 ingredients are a point and a slope. Remember, to find the point, we're plugging into regular f, the original function. So I'm going to take my -4, plug it in right there. You should get a whole number. So -4 comma something. It's an 8x squared. So that'd be an 1/8 of -4 squared. -4 squared gives me what? Okay, then divided by 8. That would be 2. Very good. So we have our x and our y. Next thing we need is our slope. Remember, f is going to go to f prime because we're taking the derivative. And then we're using our same power rules that we learned last class. So 2 times an 8. What's my new coefficient? 2 times an 8. What would that be? It would be, so let's write it over here to the side. An 8 times 2 would be like a 2/1. And then you times the tops and the bottoms. So the top of that would stay a 2. Bottom would stay an 8. What is 2/8 the same as? 1/4. So 2 times an eighth is a fourth, and then my x squared is going to power down to just a regular x. Okay? Remember, that's the slope at any x that I want, but I want the slope at my x, which is -4. So we're going to plug that in. A fourth of -4 would give me what final slope? -1. Very good. Okay, then take your ingredients, write your equation of your tangent line. So remember, you're going to start with y blank equals blank x blank. Your slope or your m goes into the middle blank. Your x and y's are going to go in opposite signs. So it'd be a -1 in the middle. My real x is a -4, so I'm going to use a +4. And then my y is a 2, so I'll plug in a -2. And then for your homework today, that answer is perfect. You can type it in exactly like that in points. Okay, however, just to check the tangency, which is what your notes are asking you to do, we're going to turn this into y equals mx plus b so that we can actually graph it and see that it touches the graph exactly at that spot. So first thing you're going to do is take that -1, times it in. -1 times x is a -1x. -1 times 4 is a -4. And then for your last step, just add that to across. So the equation of your tangent line is -1x and then -2. All right, so now take that equation, graph it, and it should perfectly touch your equation just at one point, okay, at the -4, 2 that we're expecting it to cross at. So this is my m and my b. -2 would be here. And then if your slope is -1, that should just be like a perfect downhill diagonal. Okay, so rise 1, run 1, rise 1, run 1. So go this way a few dots. And then we'll also do a few up this way. And then right here, that's where my point of tangency occurs. Okay. But that's what your tangent line should look like as it kind of barely touches your graph. Okay. One more example altogether, then you guys are going to have some time to work. So go to number 4, please. Next question. Okay, so it asks you to write the equation of a tangent line, but this time, rather than telling you part of the point, okay, it just asks you to do it at the x-intercept. Okay, so this is going to require a little bit of your algebra 2, okay, to come back that if I want an x-intercept, they're giving me part of the point, but they're not giving me the x. What y would I have to be at to be on the x-axis? So if I'm along the y-axis, what would my y value have to be? What number? 0. Thank you. That is correct. That means that y needs to be 0. So I don't have the x, but I know the y that I want for my point. So we still need a point and a slope, but this time it's something comma 0. And then we're going to take our equation of our line, and instead of plugging in 0, we're setting equal to 0. Okay? So I'm going to take 0 equal to x squared minus 4x minus 5. And then we're going to AC chart that. My A times C needs to multiply to what number? Uh-huh. And then my basement number is -4. And 5 only has one pair that will multiply, 1 and 5. But if I want to keep my 4 as a minus, which side should I put the minus on, the 1 or the 5? 5, very good. Okay, then from there, I know my factors. I have an x with a +1 and an x with a -5. Which means that my solutions, remember it's always the opposite, so it'll be -1 and +5. Now, if you look back at the question, okay, we're going to have to pick one of those. So it says, write the equation of the line tangent to the graph at its x-intercept for x greater than 0. That's going to help me pick that I want which one of these. The 5. Okay, but if it had wanted the x less than 0, I would have picked the other one. Okay, from there, we have our point. Now we need our slope. That's going to require us to take the derivative. So if my f is x squared, my f prime will be, remember, you take the 2 times this to the front, take away 1. So 2 to the front, my x is now just regular. And then for my -4x, what power is on that x, even if it's not there? The 1. So then 1 times down on the -4 is a -4. And remember, your x1 will drop to an x0, which eliminates that from the equation of the derivative. -5 is a constant, so that's going to drop off to 0. Okay, that is the derivative at any x that I want. But I want the derivative at 5. So then 2 times 5 is 10. And 10 minus 4 leaves me with 6. So then you have your point and your slope. That's enough for you to write the equation of your tangent line. Y blank equals blank x blank. My slope is a 6. My x is a 5, but I'll use a -5 in the equation, and then a -0 here. Okay. We're going to leave it just like that because that's good enough for your homework today. But remember, you can convert that into y equals mx plus b if it's a multiple choice question on an assessment. Okay, there's one other thing that we're going to cover, and it's normal lines. These are not on the AP test, but if you pass the AP test and go into Calc 2, they'll expect you to know what it is. Okay, a normal line is where instead of using the slope, you're going to take the perpendicular slope. So, do you guys happen to remember what the relationship is for a perpendicular slope? It's okay if you don't. Perpendicular slopes should be where you opposite reciprocal. Do y'all remember that from algebra 2? A little bit, maybe. So like if my slope here is 6, I would change the sign to a negative, and then I would flip it to make it a fraction. So 6 is 6 over 1. Then this would go to 1 over 6 negative. But every other part of the equation would stay the same. So it'd be y minus 0, x minus 5. Okay, the only thing that you would change for a normal line is that you would use a perpendicular slope to the one that you found. Okay, so for my class, I would expect you to know that, but for the AP test, they don't put those on there. Okay? All right, so pull out your Chromebooks, please. Okay, I'll bring you around some scratch paper, and hopefully the Google issue is fixed that you guys can log in. And then we'll finish the notes after you get a little bit. I'll tell you in a second. You have to stop at, don't do the last one. But you should be able, oh, actually, last five. Don't do last five. Yes. You want to take it? Adrian? Three with your notes last time? No. Oh, then you lost. The power roll. Okay, y'all don't move on to last five until we finish a little bit more of the notes. Can you repeat that? All right, now for the very first question, just to make sure you kind of know what you're doing on that. It's asking you to use the yellow dot to make the line tangent. So think about on this graph right now, that dotted line just cuts through it. I need it to be tangent where the yellow circle is. So I'm going to take this second yellow dot up here in the corner, and I'm just going to kind of adjust it so that my graph and my line lay right next to each other, just like the tangent lines that we did in your notes. If you did it correctly, the zoom in box should look like just one line where it's tangent, because it should be so close that there's not like a separation. Okay. All right, y'all, we're gonna just finish up this last little bit of the notes because I see some of y'all are ready to move on. So the last little bit of the notes isn't gonna change a ton of stuff. But if you'll take a look at number 5. Okay, so we still need a point and a slope. We have our f of x right here. But this time, instead of them telling you, oh, I want this x or I want this y, they're telling you that we want the slope to be 3. Okay, so put the homework to the side just for a second. Okay, so we can finish these up. So if I want my slope to be 3, then that's the answer that I want for f prime. Does that make sense? So if I want the slope to be 3, then what I'm going to do is I'm going to take the derivative, and then I'm going to set the derivative equal to the slope that I want. So take the derivative, that's going to tell me my slope, and then I'm going to set it equal to the slope that I want, which in this case we said is 3. So go ahead and do that for me. You have your f of x right here. Remember to take the derivative, you just times the exponent down, then take away 1. So if I want my derivative, f prime of x equals 3 times a third is how many? 1. And then x squared now. Because remember, I have to take away 1 from the power. Okay, then for my minus x, that's a minus 1x to the 1. So 1 times 1 is 1. My x will drop down to go away because it was already an x. It would go down to 0 when you reduce it. Okay, then that's the slope anywhere, but I want the slope to equal 3. So I have 1x squared minus 1, and I need that equal to 3, and then we're just going to solve that. So my minus 1, I would undo that with a plus 1. 3 plus 1 is 4. And if 4 is x squared, then take the square root on both sides, and what is my answer going to be? Plus or minus 2. Because remember, when you take a square root, technically you should still be getting 2 separate answers. Okay, now for your homework, this is important. Sometimes it'll just ask you to find the x values. And if it does, 2 and -2 is the answer. But look at the way this question asks. It says to find the coordinates of the points. So if I need points, I need x's and y's. So I know that I'm going to have 2 comma something and -2 comma something. But where will I get the y values that go with those x values? What will I plug into? Not the derivative, but the original equations. Okay, remember, y values come from the original, slope comes from the derivative. So now that I know my x's, I can plug back into the original to find the y's that go with them. So let's do +2 first. So I have a third of +2 cubed minus 2. So let's write here, find y values for the points. So what's 2 cubed? 2 times 2 is 4 times 2 is 8. So I want a third of 8, which is the same as 8/3. And then if I want a -2, I'm going to times that by 3/3 so that that is measured in thirds as well. So for my -2, I'm going to 3/3 that. So that really, what am I minusing as a fraction? 2 times 3/3 would go to 6/3. And what's 8/3 take away 6/3? 2/3. So my first ordered pair would be 2, 2/3. Okay, then let's just be a little bit lazy and change our 2's to -2's so we don't have to rewrite the whole thing. Okay, so now instead of 2's, they're -2's. So minus and minus. What is -2 if I cube it? What kind of 8? -8, which means this is a -8/3. And then if I'm doing a minus on a -2, what's that going to change to this? Now it's a plus, which will turn into a +6/3. -8/3 plus 6/3 would be -2/3. Okay, but you only have to do that last little step if it's asking you for the coordinates of the points. If it only wants an x value, you wouldn't have to go back and do that. Okay? All right, we have 2 questions left. Turn the page. So if you have the slope that you want, you take the derivative, set it equal to that slope. Turn the page. Okay, number 6 is kind of the same thing, so we're going to skip it. Take a look at number 7. Okay, this time I want to use my equation and I want to find the values of x. So notice I don't need full coordinates. I don't need an x and a y, just x is good enough. But I want the graph to have a horizontal slope. What number does horizontal slope need to be? Perfectly flat, horizontal means a 0 slope. So you're going to still take the derivative, but then you're going to set it equal to 0. So they're still basically telling you a slope that they want, but they're just saying horizontal, but you should know that means a 0 slope. So take the derivative of that for me. And then we're going to let it equal 0. So f prime of x is 3 times 2 is a 6x squared. Okay, remember I'm dropping that power by 1. Next term was a 3x squared. So 2 times 3 is 6. Drop it to a regular x. And then 36x doesn't have a power. Well, then I know it's a power of 1. So 1 times 36 is 36. Your x drops off to a 0 power. And then if this is the slope wherever I want, I'm going to set it equal to 0. What can we take out of all those terms? 6. So my 6 is going to come out. That gives me an x squared plus 1x minus 6. And then we can AC chart it. So A, B, C. Now notice your A is a 1. Okay, the 6, we pulled that out. That's not part of the AC anymore. So if you want to just put your finger over it, pretend the 6 isn't even there. So 1 times -6 is -6. I need a basement number of 1. What factors could I use? 3 and 2. And if I want to keep the 1 positive, where should I put the negative? On the 3 side or the 2 side? 2, very good. So my factors are x plus 3 and x minus 2, which means that my solutions are the reverse signs to that. So it'd be x equals -3 and x equals +2. Okay. So if it asks you for a horizontal slope, that's how you're going to do it. Good so far? 1 question left. Turn the page. Okay, the last question type that we're going to look at is if it's asking you to make things parallel. So take a look at number 9. This is the last question we're going to do in your notes today. Okay, number 9 says that we want to take this equation and make it parallel to this equation. What do you remember about parallel lines and their slopes? They have to be what? For them to be parallel. The same. So right here it says when graphs are parallel, they have the same slope. And if they have the same slope, then they need to have equal derivatives. So if you want 2 things to be parallel, you're going to take both of their derivatives and then just set them equal to each other. So instead of having an exact slope that you want, you just want their slopes to equal each other. Okay, so let's do that. Okay, let's start with f prime of x. And then we're going to set it equal to y prime. Okay, where f prime is the derivative of the first equation, y prime is the derivative of the second equation. Okay, take your derivative of f. Somebody want to tell me what it is? Yep. Minus plus 2. And then remember that your x is going to fall off of that 2x because when I power it down, it goes away. Okay, derivative on 3x minus 4, what would you get? Remember, that's like a 3x to the 1. It'd just be 3. Good job, Alberto. That's right. Okay, then from there, it's still quadratic. Remember, your strategy in solving quadratics is everything on the same side then factor. So my 3 is going to have to subtract across on the 2. So I have 3x squared minus 2x minus 1. A, B, C. I need numbers that multiply to what? -3. And then a -2 at the bottom. The only way to get 3 is 1 times 3. And then where should I place the negative? 3 side. Okay, now this is important. You might have forgotten this. I think on the first day when we did that prerequisite challenge, I just was too lazy to go back over this. But if your A is a 1, you can go straight to the factors. Do you remember we'd put x plus 1 and x minus 3? You can't do that if your A is anything besides 1. In this case, what's my A? 3. Then you're going to have to do grouping. So let me remind you how to do that. Okay, so I'm going to put here factor by grouping because your A is not just a 1. Okay, if it was a 1x squared, we could shortcut that all day, just like we've done pretty much all year. But if it's something other than that, you're going to have to do grouping. Let me remind you how to do it. Okay, you're going to keep your 3x squared the same. You're going to keep your minus 1 the same. So the first and the last terms are going to stay the same. But my 3x and my 1x are going to both go in the middle. Now, you can put them in either order. So I'm going to put the -3 first and the +1 second. But I want you to consider, do I still have the same number of x's altogether? The answer is yes. Here I have a -2x. Here I have a -3x and a 1x, but that still adds back to -2. Okay, then you're going to underline your groups and take out the GCFs. For the first group, what can I take out of both? Great, 3x. When my 3x comes out, my 3x squared is just an x. My second term is a -1 because when the 3 comes out, you have to leave something. Okay, for my second group, I have a 1x minus 1. What can I take out? 1, put a +1 on the outside. That leaves me still with an x and a -1. At this step, if your parentheses match each other, you did it correctly. So I have an x -1 and an x -1. And then my second factor comes from whatever I pulled out. So it was a 3x and a +1. Then from there, we're ready to identify our answers. So if it's an x -1, what's the answer? +1, good. And then for the 3x + 1, I don't know if you remember this little shortcut, but the 1 still turns to a -1, and then you just divide by 3. Because if you think about solving it, your +1, you'd subtract it across. And then to get rid of the 3 on the x, you just divide it. Okay? But you only have to do that grouping if your A in the front isn't just like a regular 1x squared. Okay? All right, so you shouldn't get too many of those on your homework, but you just could get one. Okay? All right, you still have about 25 minutes, so ask me if you need any help.
Sorry.
Yeah.
Can I get a